Okay, now this time, this is a power problem. Calculate the time needed for a 2.5 kilowatt electric motor that performs 75,000 joules of applied work. So our formula for power is work divided by time. But we are asked for the time, so we have to do some manipulation. What can we do first? Let's multiply time on both sides of the equation. In this case, we cancel the time on the right side of the equation. On the left side, we have time times power. But we are only concerned with time. You divide this by power, both sides. So actually, our unit for time, or our formula for time derived from the power equation will be work divided by power. Work, remember, is in joules. Power is in joules per second. So you cancel the joules, and then you get the reciprocal of 1 over s in the denominator, and the final unit will be in seconds. So time is work, that is 75,000 joules. Power is 2.5 kilowatts. So this time, to convert that to watts, you multiply by 1,000. Or you move the decimal place. 1, 2, 3. Three places to the right, since 1,000 has 3 zeros. Watts. Time will be the quotient of the two, equivalent to 30 seconds. Okay, here's another. Solve the work done by a 500 watt electric mixers in 2.5 seconds. Power is work divided by time. This time you're interested with work. You're given with the power, 500 watts, and the time in minutes, which later on you have to convert to seconds. So multiply both sides by time. Now, work is power times time. Power is 500 watts. Time is 2.5 minutes. I have to convert this to seconds. There are 60 seconds per minute. I can cancel the minute unit. I am left with seconds. Remember, watts is joules per second. So joules per second times seconds from here will be joules, which is the unit for work. 500 rather times 2.5 times 60 will be 75,000 joules, or divided by 1,000, 75 kilojoules. Now here is our answer. Next one. Calculate the power made by a 50 kilogram boy running up the stairs with a height of 3 meters in 2.5 seconds. Okay, so just like the previous problem, power will be work divided by time. We're given with the time, 2.5 seconds, but not the work. So we have to solve for the work. It's force times the displacement. Actually, we can do some modification here. Work is how much work should the boy apply on himself to lift him up the stairs. It should be equal or greater than his weight, or the gravitational force. So let's just say the minimum, which is equal to the gravitational force. We can also change the notation here for displacement, since you are moving upwards, moving along the y-axis. So instead of change in x, we use change in y. How do we compute for the FG? Mass times acceleration due to gravity, 50 kilogram times 9.8 meter per second squared. What's that? 50 times 9.8, 490. Kilogram times meter per second is newtons. That's my force. And I need to be displaced. The boy need to displace himself by 3 meters. So what's the product? 1,400 and wait a minute. Yes, 1,470 joules. Let me verify. 490 times 3. Yes, 1,470 joules. Now I can finally compute for the power. 1,470 joules of the boy since he climbed the stairs in under or in 2.5 seconds. So 1,470 rather divided by 2.5, 588. 588 joules per second is watts. Okay, I think this is the last one for this set. How many hours will it take for a 500 watt electric drill to work for 100 kilowatt hour? Okay, so we're given with two power here. The other one is kilowatt hour. So we are actually familiar with kilowatt hour. Usually our electricity bills are in kilowatt hour. So it's how much kilowatt we use multiplied with the total number of hours we are using the, let's say, appliances, or we are consuming energy. So how do we get hours? They are asking for hours. If we have a watt and a kilowatt hour given. So let's first convert the kilowatt to watt. So 100, if you want to convert that 100 kilowatt, if you want to convert to watts, will be 100,000 watts. The unit is in watts per, in watts hour. Kilowatt hour to watts hour. But if we divide this by 500 watts, we can get to cancel the watts and we are left with hours, which is the unit that we wanted in the first place. So doing the division, what we will have is 200 hours. Okay? Next, we will be discussing gravitational potential energy and relative potential energy.